Welcome to the Calculus, a collection of micro lectures, video lessons, and sample exercises. Let's compute the limit of the natural logarithm of x as x approaches to 1 using table of values. This is a continuation of illustrating the limit of logarithmic functions using table of values. In the previous video, we used there a function which is the logarithm of x to the base 10. We're able to illustrate its limit using a table of values from the left and right of 1. This time, we are going to use the natural logarithm of x as x approaches to the same value of 1. Again, that is our f of x. And we are to compute or illustrate the limit of the said function as x approaches to 1 using table of values. Hence, we'll be using here two sets of tables. From the first one would be the values of x from the left of 1 and then from the right of 1. Take note, this is still under logarithmic function, and natural logarithm of x is also an example of a logarithmic function. Hence, this follows the idea that the possible values of x, as we try the values of x from the left of 1, we cannot use here the negative values nor 0, because the possible values of x in the domain of the natural logarithm of x are all values of x greater than 0. This is in connection with the idea that logarithms are transformations, or logarithmic equation or functions are transformations from equivalent exponential functions or exponential equations, where whatever would be the value of the exponent, the value will always be either 0 or positive. So we can never get a negative value for an exponent. Hence, in this case, for the logarithms or logarithmic functions, we cannot use the negative values. Hence, what we can use here is 0.1, just a possible value, not necessarily the least, because you could also try here 0.0001 if you would like to, but let's try with this value. As we plug this in to our f of x, take note this table is from the left. Okay, as you plug this in using your calculators, you will have an approximate value of negative 2.3026. As mentioned, it's approximation because you only have 4 decimal places. This value cannot tell us the limit of the function as x approaches to 1 from the left. So let's continue and use other values. Let's have 0.5 or 1/2. As we plug that in on our given function, you will have here an approximated value of negative 0.6931. Let's try more values, getting closer to 1 from the left. So you have 0.9. Okay, as you plug that in, you will have negative 0.1054. Probably you could see a pattern here, but this is not necessarily enough because we need to look into the smaller values getting closer to 1. So what if I would add here 0.99, so it gets closer to 1 now, even adding 0.999 or 0.9999. So they're all getting closer to 1. Again, as x approaches to 1, find the values on the left of 1. So again, you can use your calculators here, plug this in your calculators. For 0.99, you can have here negative 0.0101. Okay? As you move to the next value, you will have negative 0.0010. And then trying the value of 0.9999, the value even closer to 1 from the left, you will have an approximation of negative 0.0001. As you can see, when you examine all these values, it gets closer to a specific number, which is 0. This is the limit of the natural logarithm of x as x approaches to 1 from the left. Okay, so let's try all those values now from the right of our 1, x is equal to 1. Of course, this now includes a large possible set of values, but let's try here the integer 2. You can try more, but let's just simply try 2, and let from that we'll get closer to 1 from the right. As you plug into here, you will get an approximated value of 0.6931 as x is equal to 2 in this case. Okay, so let's try adding more values. So let's have here 1.5. As it gets closer to 1 now, it's even 1/2 as compared to 2. So plugging that in, you will get here an approximation of 0.405 and 5. Now let's move closer to 1. You'll have 1.1. You could have here 1.01, 1.001, and 1.0001, just to illustrate the limit using this table of values. Plugging them in one by one on our calculator, let's start with 1.1. You will have 0.0953. For 1.01, you have 0.0100. Next, for 1.001, you'll have 0.001 and 0. So you can see we have the same pattern, or probably the same value as it gets closer to 1. So let's have the remaining value. You will have here 0.0001. Okay? Clearly, as x approaches to 1 from the left, the value of f of x is also getting closer to 0. These two values are just the same. Take note, this value here, the first one from the left, you can write it like this. Natural logarithm of x as x approaches to 1 from the left is just equal to the limit of the natural logarithm of x as x approaches to 1 from the right, and they are both equal to 0. From here, we can now say that the limit of the natural logarithm of x as x approaches to 1 is also equal to 0. This is since the value from the left, or the limit from the left and from the right of 1 are both equal to 0, and they are equal to one another. Hence, the same value is true for the limit of the natural logarithm of x as x approaches to the value of 1. So what are you waiting for? Subscribe now.